In this video, we will talk about computed Dirichlet integral equation and various applications of infinitesimal analysis. We obtain a new possible mathematical connection with the MRB Constant, some sector of number theory and string theory. This is the picture of Peter Gustav Lejeune Dirichlet and Vesuvius landscape with gorses. Naples, Italy. Naples. Now, we have the following expression. Here. This is the input and the exact result. Wolfram Alpha, the program that we have utilized for our calculation, show also the three-dimensional plots, figures that we relate to the Brane instantons, the Brandt's instantons. Yes, we hypothesize that the three-dimensional plots of H expressions that we analyzed represent a possible figure that can be related to the Brandt's instantons. This is the real part, the first picture, the first plot. The second plot containing the imaginary part. Okay. After there are the alternate forms, expanded forms, series expansions at m equal to 0, series expansions at m equal to infinite. The derivative, the indefinite integral, the alternative representation, the series representation, the integral representation, the multiple argument formulas. Now, from the exact result that we have seen above, for m equal to 8 and p equal to 64, we obtain this exact result. The following exact result. In polar coordinates, we have the following value. Again, alternate forms, alternative representation, and so. From which, then, from the last expression, after some calculation, we obtain this other result, that in polar coordinates give this value, a value very near to pi greco squared divided by 6, practically z2, a value of the Riemann zeta function. Z2 is a value of the Riemann zeta function. We hypothesize that it's connected also with the trace of the instanton shape. Okay. And Z2, that is pi greco squared divided by 6, is a recurring number. Is a recurring numbers. Now, again alternate forms, expanded form, and so. Now from this integral we obtain, after this calculation, the three-dimensional plots. Also here the real part and the imaginary part. And again the figures can be related to Brandt's instantons. We can see the first plot, real part, and the second plot, the imaginary part. Again, alternate forms. Now, for the previous equation, this is the input, this is the result. We have the following three-dimensional plot, then figure that can be related to the Brandt's instantons. Again, the first figure is the real part, the second figure containing the imaginary part. Again, alternate forms, expanded forms, real roots, properties are as a real function domain, derivative, indefinite integral, and from the result that we obtain above, for x equal to and p equal 12, we obtain the following result, that in polar coordinates is the following value. Also here we obtain alternate forms, expanded form, alternative representation, and so. From the previous expression, after some calculation, we obtain another exact result, that is the following value that is very near to zeta2, a value of a Riemann zeta function, that is equal to pi greco squared divided by 6, and is connected with the trace of the instanton shape. This is the alternate forms. Now we have this other expression. This is the input. This is the exact result of the first expression. Also here we have the three-dimensional plots, figures that can be related to the Brandt's instantons. Also here we have the real part, that is the following figure, and the imaginary part, that is the following image. Also here alternate form, expanded form, and so. Series representation. This is the second expression that we have the following exact result, and also here the three-dimensional plots, and that represent figures that can be related to the Brandt's instantons. This is the real part, the plot containing the real part, and this is the plot containing the imaginary part. Also here, alternate form, expanded forms, and so. Now, from the two exact results, the first and the second, we obtain from the sum. This is the input, and this is the three-dimensional plots. Then the figure that can be related to the different instantons. This is the first concerning the real part. This is the second concerning the imaginary part. Also here we note the alternate forms, the expanded forms, and so. From the following alternate forms, we have the following. After some calculation, we obtain for m equal to 8 and p equal to 12. This is the input. We have the following result. That is, in polar coordinates, the following value. Also here, alternate forms, expanded forms. Now, from the previous expressions, after some calculation, this is the expression, okay, into the parents. So, we have the following results. The result that in polar coordinates is equal to a result that is a very good approximation to the value of the golden ratio. Okay. Also here, alternate forms, expanded forms. Now, multiplying the two exact results, the first and second, we obtain, this is the input of the data, we obtain this exact result. The three-dimensional plots, then the figures that can be related to the different instantons, the real part, the first plot is the real part, the second plot represents the imaginary part. Also here, alternate forms, prove series expansions at m equal to 0, series expansion at m equal to infinity, derivative, indefinite integral, and so. From the exact result that we have obtained above, for m equal to 8 and p equal to 12, we obtain this result and this value, from which then from the last expression we obtain, after another some calculation, this fourth result that is 4096, that multiplied by 2 gives 8192. 8192. That corresponding to the gauge group SO 80,192. It is fundamental in the open bosonic string theory. Now, for this further calculation, we obtain another results, precisely a value that is very near to the mass of candidate gluable scalar meson. Furthermore, (1728) occurs in the algebraic formula for the J invariant of an elliptic curve. The number 1728 is one less than the Hardy-Ramanujan number 1729. That is also called taxicab number. Also here we obtain alternate forms, and in conclusion, performing the 15th root of 1729, and after some easy calculation where we observe also the MRB constant that we utilize as regularizer. Then the exact result is the number is a value very near to zeta2 choose pi greco squared divided by 6. That is related to the trace of this instanton shape. Also here alternate forms, and so. The so-called recurring numbers are 1729, 4096, zeta2, that is pi greco squared divided by 6, given by the 15th root of 1729. This is the so-called Hardy-Ramanujan number, and is very close to the mass of the candidate gluable. The F0 1710 scalar meson. Furthermore, 1728 occurs in the algebraic formula for the invariant J of an elliptic curve. Number 1728 is one less than the Hardy-Ramanujan number 1729. That is a taxi number. 4096 multiplied by 2 gives 8192. In fact, the total amplitude vanishes for the measurement group SO 8192, while the vacuum energy is negative and independent of the measurement group. The vacuum energy and the dilaton tadpole at the lowest non-trivial order for the open bosonic string, while the vacuum energy is different from zero and independent of the measurement group. The dilaton tadpole is zero for a unique choice of measurement group S0 8192. These numbers are mathematically connected, but the sum parameters of the theory of numbers theory and string theory. Furthermore, zeta2 and the golden ratio, we hypothesized that they can be connected to the geometric shapes, variety or Calabi-Yau space, that are formed by the compactification, by the winding of the 6 or 7 additional dimensions that contemplate both the string theory and the M theory. We believe in the possibility that number theory, especially Ramanujan's mathematics, with its fundamental work, modular equation and approximation to pi Greco, could lead in the not too distant future to the unification of fundamental physics interaction, at least from the point of pure mathematical. Thence, we believe in the possibility that the number theory, especially Ramanujan mathematics, with its fundamental work, modular equation and approximation to pi Greco, could lead in the not too distant future to the unification of fundamental physical interaction, at least from the point of purely mathematical. Thank you very much.